discuss some of the capabilities and potential that you're able to reach with these modalities?
Yeah, so I think that AI can do a lot of different things again, and one of the things it's been used a lot to discover kind of new things, but one of the things that we've been very concerned about, at the Buffalo Neuroimaging Analysis Center, we are very closely associated with the neurology clinic here, and so we see a lot of the day-to-day needs. And one of the things that AI can really shine at is processing data that may not be perfect research quality. So we do these scans all the time in a research setting to find things out about the disease, to measure, for example, brain atrophy. So we measure the loss of tissue over time in clinical trials where we have very nice, highly standardized MRI protocols. We hold them constant over the years of the study. We can take an hour of scanning time, and that just doesn't happen in clinical routine. And so one of the biggest challenges that I see is that you don't have, is that those metrics that we're able to get in clinical trials and in a research setting aren't always translatable to the clinic. And AI is really, I think, a tool that can help bridge that gap. So one of the things we worked on a lot in the last couple of years is, instead of making new methods, using AI to translate these kind of existing metrics that we use in clinical trials to work on clinical quality images. So, one of the biggest things that we did recently is called deep gray, which is deep gray matter rating via AI. And essentially, it's a tool to measure thalamic atrophy. So we know thalamic atrophy is extremely important in MS. It's a strong predictor of clinical disability, of cognition. The thalamus tends to atrophy relatively steadily over the disease, so it's also potentially a good biomarker for treatment response, but it's not measurable in clinical routine. And so we took 4,000 scans from all kinds of different centers and data, and we were able to use that data to train an artificial intelligence system to automatically delineate and locate the thalamus on what's called a T2 flare image, which is the lowest common denominator kind of imaging. So that's an image that anybody who goes to any clinic, pretty much anywhere in the world for MS, they're going to get a T2 weighted image as part of a standard of care MS protocol. And so now we have a tool that can actually make these kind of clinical research measures, but can make it on these routine clinical images.